A quote can still display $100 bid and $100.02 ask, while the data behind it has already failed. The source timestamp may be old. The packet may have arrived late. The price may not have changed for too long, or the feed may have stopped speaking altogether. Those are 4 different failures, and they should not collapse into one vague stale flag. A trader needs to know whether a displayed market is usable. An engineer needs to know which clock failed, which evidence is trustworthy, and whether the detector changed state after a bad event. This lesson builds that diagnosis without pretending an unchanged price always means an outage. We will build the stale quote detector as one stateful diagnostic. You will learn the ownership of 4 clocks, the exact greater than and greater than or equal boundaries, the event anchors that heartbeats and quotes are allowed to update, and the session policy that separates raw age from business staleness. Then we will walk the canonical event sequence, reject clock skew before mutation, inspect a basic TypeScript implementation, and use the shared fixture to verify Python and TypeScript parity. Exchange calendar alignment supplies the session expectation. Feed latency monitor can add richer transport distributions. Here, the job is narrower. Classify freshness honestly, preserve uncertainty, and return reasons that another system can audit. Before calculating age, separate the 2 clock domains. Source event age compares the evaluator's current time with a timestamp written by the venue or feed. Transport age compares receiver time with that same source timestamp. Both cross machines, so they are meaningful only when clock synchronization is explicitly verified. Unchanged duration and heartbeat age are different. They compare timestamps captured inside the receiver, so they stay in one clock domain. A production system should also retain a monotonic local clock for elapsed time safety. This reference uses UTC timestamps for reproducibility, rejects time that moves backward, and never hides a negative age by clamping it to 0. Clock ownership is part of the data contract, not a formatting detail. The detector consumes 3 event types. A quote carries bid, ask, source time, and receiver time. A valid quote refreshes the latest quote and proves liveness. It changes the last price change anchor only when bid or ask actually changes. A heartbeat proves that the feed is active, but it does not invent a new quote and does not reset unchanged duration. A check event advances evaluation time without updating any anchor. Every event also carries a session identity, session state, and whether activity is expected. When the session identity changes, the detector resets before processing the new event. That rule prevents yesterday's quote, heartbeat, or change anchor from contaminating today's diagnosis. Now, calculate the 4 ages from their anchors. Source event age is current evaluation time minus the latest quote's source time. It asks whether the source evidence is old now. Transport age is quote receive time minus quote source time. It asks whether that packet was already late when received. Unchanged duration is current time minus the receive time of the last bid or ask change. It asks how long the economic quote has stayed identical. Heartbeat age is current time minus the last accepted message time. It asks whether the feed is still alive. One quote can therefore have a fresh source age, a long, unchanged duration, and a healthy heartbeat at the same moment. The clocks are related, but none is a substitute for another. The policy thresholds are explicit. Source event age is old only when it exceeds 1200 milliseconds. Transport is late only when it exceeds 250 milliseconds. Heartbeat loss requires expected activity and an age greater than 1200 milliseconds. Unchanged duration is the deliberate exception. It triggers at 3000 milliseconds or more. So equality is accepted for source, transport, and heartbeat, but equality triggers unchanged duration. Business stale is also narrower than raw diagnostics. During an active session with expected activity, it becomes true when source age is old or unchanged duration has reached its threshold. Transport lateness and heartbeat loss remain separate reasons. They are operationally important, but neither silently becomes business stale. Walk the canonical sequence. The first quote has a source time of 9:30 exactly and arrives 100 milliseconds later. At 9:30 and 1.2 seconds, source age equals 1200 milliseconds. The strict rule has not fired. A later quote arrives with the same bid and ask at 2.5 seconds. It refreshes source age and heartbeat, but the last price change anchor stays at 100 milliseconds because the price did not change. At 3.3 seconds, a heartbeat arrives. Liveness is healthy, yet unchanged duration is now 3200 milliseconds. The result contains unchanged duration and business stale. This is the key distinction. A speaking feed can still carry an economically stale quote. Continue the sequence. A change quote arrives at 3.55 seconds. Because bid or ask changed, the last change anchor moves and unchanged duration resets to 0. Later, one quote arrives with transport age exactly 250 milliseconds. The strict transport rule accepts it. The next quote arrives 251 milliseconds after its source time, so transport age appears as a reason. The quote may still be fresh by source age, and transport lateness still does not set business stale by itself. This 1 millisecond contrast is not trivia. It locks the boundary semantics shared by the article, fixture, Python, TypeScript, and the system that consumes the output. Stateful detection makes validation order critical. A quote must be rejected before mutation when timestamps are missing or invalid. Clock synchronization is unverified. Transport age is negative. Source time moves backward. Observed time moves backward, or bid and ask are missing, non-finite, or non-positive. The reference deliberately treats crossed or locked markets as a separate detector. Now inject a clock-skewed quote whose source time is ahead of receive time. The detector returns an invalid result with clock skew, but the stored quote, last change anchor, and last message anchor do not move. The next valid check proves those anchors were preserved. Validate, then reset when required, then mutate, then calculate. Reordering those steps can make one rejected packet corrupt every later age. Compare the detector's distinct terminal states. In normal flow, prices or timestamps refresh within policy and every age remains acceptable. In an unchanged price scenario, heartbeats continue while the change anchor ages. The feed is alive, but business stale can become true. In heartbeat loss, expected activity continues and the last message age exceeds its threshold. That is a liveness failure even if the displayed quote recently changed. Before any quote, source and transport ages are null. The record is unusable, and no quote is explicit. With clock skew, the event is invalid rather than mysteriously fresh. The value of the classifier is not the red badge. It is the ability to preserve these different explanations for operations, monitoring, and downstream policy. Raw age and business meaning must remain separate. Outside an active session, an old source timestamp can still produce a large raw source age, but the detector suppresses business stale. During a halt, activity may not be expected, so heartbeat loss is suppressed as well. The caller owns that expectation through a versioned exchange calendar that accounts for time zone, holidays, early closes, auctions, halts, and the actual feed window. The detector does not infer an official schedule from silence. It receives session state and activity expected on every event, reports the raw diagnostics, and applies business classification only when policy allows it. That is where exchange calendar alignment joins this detector. The calendar decides when absence is meaningful, The 4 clocks explain what kind of absence occurred. The TypeScript implementation can stay readable because the contract already made the hard choices. First, validate configuration and the incoming event. If the session identity changed, reset state. Then mutate only the anchors owned by that event. Next, calculate nullable ages from the stored anchors. Finally, derive ordered reasons and the business stale flag from explicit session policy. Notice 3 small details. A same price quote updates the latest quote and liveness, but not last change. A heartbeat updates only liveness. And before the first quote, quote-dependent ages remain null. The Python implementation follows the same order. Both return diagnostics with value state. For ages, business status, usability, session metadata, and reasons, so consumers do not have to reverse engineer one Boolean. The shared fixture contains 12 ordered events and exact expected results. Both languages must agree on the first quote, the 1200 millisecond source equality, the same price anchor, the 3200 millisecond unchanged state, the change price reset, and the transport boundary at 250 versus 251 milliseconds. Additional tests cover heartbeat-only flow, heartbeat timeout, no quote, invalid configuration, missing fields, non-finite prices, unverified clock synchronization, backward time, session resets, and rejected events that leave state unchanged. These tests prove conformance to the written contract and cross-language parity. They do not prove that the thresholds are optimal, that stale quotes predict returns, or that the detector is profitable. Threshold calibration needs provider-specific telemetry and operational objectives. A real incident makes the distinction concrete. On August 22, 2013, the UTP quote feed for tape C experienced intermittent disruption near 11:48 Eastern. Outbound quote channels ceased near 12:03. The technical issue was reported resolved and stable around 12:24. Control connectivity return began around 2 o'clock, and quoting and trading in tape C securities fully resumed around 3:25. Yet UTP trade feeds continued, and NASDAQ proprietary feeds were reported normal. The SEC described a securities information processor failure that prevented quote processing and contributed to a market-wide halt. One frozen consolidated quote could not tell you this cause. Source identity, message type, heartbeat, session policy, and recovery phase all mattered. Technical repair time and market reopening time were not the same event. You can now diagnose quote freshness with 4 clocks instead of one ambiguous stale label. Keep source age, transport age, unchanged duration, and heartbeat age visible beside their reasons. Preserve null before the first quote. Reject invalid time before mutation. Separate raw diagnostics from active session business policy. And keep the feed, venue, symbol, session, timestamp basis, and clock sync status attached to every result. The limitations matter. Quiet symbols can remain unchanged legitimately. Heartbeat proves liveness, not economic freshness. Size-only changes are ignored by this reference. Recent timestamps do not prove sequence completeness, and one feed cannot establish cross-source truth. The full stale quote detector article on the fintechbuilder.com includes the complete contract, fixture, Python and TypeScript source, tests, references, and interactive playground. Next, Duplicate Trade Resolver asks whether repeated prints are legitimate events or duplicates that must be removed without deleting real trading activity. Continue with the full stale quote detector article and playground on the fintechbuilder.com. The article link is in the video description.